Moon phases and tides, Hexagon vocabulary. I can relate the positions of the moon and the sun to their effect on ocean tides.
Some things science can't explain. Tide goes in, tide goes out. You can't explain that. I'm kidding, we can totally explain that. What's up, our semi-diurnal viewers? Julian here for D-News. Over the weekend, the coast of Britain was hit with big waves and some of the highest tides in 20 years. What's causing these huge tides? And why do we even have tides at all, for that matter? Well, most people are taught that the moon controls the tides, and that's pretty much where their education ends. While that's most of what you need to know, it may be a bit confusing when you look closely. It's logical that water would be drawn towards the moon because of its gravitational pull, causing a tidal bulge in that direction. Weirdly, though, a tidal bulge also forms on the opposite side of the planet, and there's no secret moon over there. So what's going on? Well, you have to remember that the moon's gravity isn't just pulling on water, it's pulling on the whole Earth, too. Water closest to the moon gets drawn toward it hardest. The Earth gets tugged toward the moon a little less vigorously, and the water on the far side of the Earth is pulled much less, so essentially it's being left behind and forming its own little lump. Our moon has a slightly elliptical orbit that varies how far away it is by about 50,000 kilometers each month. When it's closest, or perigee, tides are more pronounced than when it's farthest at apogee. Another factor affecting the tides is land. If the Earth had no Earth, then the tidal bulges would stay in line with the moon while the planet and its water spin under. But luckily for things with legs, we do have land. The continents keep the water from flowing freely, and it complicates tidal patterns. Most places get two alternating high and low tides a day. If the highs and lows are about the same, it's called semi-diurnal. If they're different, it's a mixed semi-diurnal pattern, and if they get one high and one low tide a day, it's diurnal. The moon is the biggest factor at work, but the sun's getting in on the action too, with solar tides being about half as big as lunar tides. When the sun and the moon are aligned twice a month, we experience extreme highs and lows called spring tides because their powers combine. When the sun and the moon are at right angles, their gravities smooth out the bulges, and the less extreme differences are called neap tides. Over the weekend, Britain was on the wrong side of all of these factors. The moon was in perigee, in line with the sun. Bad luck, but it was bound to happen eventually. At least there's no vengeful Anglophobic curse at work that we can't explain. While it's true there are plenty of things science hasn't figured out yet, we've got tides pretty much unlocked. So the outside of the planet obviously has a lot going on, but there's plenty of movement and shaking under the surface too. Trace talks about what we figured out in this video.
The new model has revealed the moon-sized inner core is super rotating in an easterly direction, and the outer core is flowing much slower in a westerly direction.
Some things science can't explain.
Let's practice. Explain the differences in tides caused by the position of the moon and the sun. So in diagram A, we have the sun, the earth, and the moon at a perpendicular angle or 90-degree angle. So we have neap tides. Neap tides, 90-degree angle. The moon's gravitational pull is pulling on Earth's water in this direction, and then the sun's gravitational pull is pulling on Earth's water in that direction. So you have your least effect between tidal ranges. You don't have a big difference between high and low tides. Diagram B. Here we have the sun, the moon, and the earth in a straight line. We call these spring tides. Spring tides are where you have the greatest effect between tidal ranges. So here you're going to have very high tides and very low tides when the moon is in between the sun and the earth. So at the new moon position, also at the full moon position. Spring tide, straight line, meaning you have the greatest effect between tidal ranges, high tides and low tides. Instructions, slides 4 to 5. Read the informational text on slides 4 to 5 to build background knowledge. On slide 6, we're going to drag and connect cards to demonstrate your understanding about moon phases, position of the moon, and tides. You may make one big connection or a couple of smaller connections. Slide 7 through 8 complete STAR test questions. Tides are the periodic rise and fall of large bodies of water. Tides are created because the Earth and the Moon are attracted to each other by the force of gravity. The gravitational attraction of the Moon causes Earth's ocean to bulge out in the direction of the Moon. When the Moon, Sun, and Earth are in a line, the gravitational pull of the Moon and the Sun are combined. At these times, the high tides are very high and the low tides are very low. This is known as a spring tide. Spring tides are especially strong tides and occur during a full moon and a new moon. Spring tide straight line, greatest effect between tidal ranges. You have very high tides and very low tides. So, two high tides, two very low tides in a day. When the moon and when the moon, sun, and earth are not in a line, the gravitational pull is not as great. The result is a smaller difference between high and low tides. These are called neap tides. They occur when the gravitational force of the moon and the sun are perpendicular to one another. Neap tides occur during the first and last quarter of the moon. So, neap tides, 90-degree angle. They occur at the first quarter and the third quarter moon phases. The moon is pulling on Earth's water in one direction, and the sun is pulling on Earth's water in another direction. You do not have a great effect between tidal ranges. So, your low and high tides are pretty much the same. All right, this is where we're going to drag around our pictures and vocabulary to make a connection. So I'm going to minimize my screen so we can try to do something together here. So I'll just start with full moon. Okay, and I'm going to leave this line 180 degrees. That's a straight line. You have a full moon and a new moon. I know that these are spring tides, right? So I'd kind of want to make that connection of a spring tide. So we can drag this little vocab word up here, probably with full moon, spring tides. Okay, that would also be with a new moon, wouldn't it? So we can also put that in there, maybe over here because it's labeling that new moon position. So it's up to you how you want to arrange your hexagon vocabulary. So I see a waxing crescent and I see two waxing crescents over here. Waxing crescent, we have light on the right. So let's associate these two together. A waning crescent is where you're losing that light on the right. So these cards go together. So we can maybe move this one down here. And then neap tides are at 90-degree angles. Those also occur at your first quarter and your third quarter, but I do not see pictures there. We could probably connect the neap tides and spring tides because those are associated with tides, right? Neap tides with 90, we can put that there. So you just kind of want to make some connection to yourself with these terms, and that's up to you how you arrange it and your thought process. I'm just going to put those cards back the way they were. And going to the next screen, we have a star test question here. So I'm going to present my screen. It reads, if there is a third quarter moon July 2nd, what is the approximate date of the next full moon? So when you get a calendar question on moon phases, you must do a brain dump. Doing this little diagram on your paper is going to help you answer any type of calendar question. So we're July 2nd, we are a third quarter. So I'm going to find my third quarter position, and this is July 2nd, and I want to know when the approximate date of the next full moon is. So I would have to count moon phases. So remember, every two moon phases takes a week. So 1, 2, that's a week. 1, 2, that's a week. 1, 2, that's a week. So pretty much it's going to take me 3 weeks to become a full moon. So if I'm here July 2nd at a third quarter, I have to count 3 weeks. 1, 2, 3 weeks. So I would be a full moon July 23rd. Star connection question. Different relative positions of the sun, the moon, and Earth have different effects on Earth's ocean. Which model shows the position of the sun, moon, and Earth that have the greatest effects on ocean tides? Remember, spring tides, straight line. Those are the greatest effect between tidal ranges. So you want to look at the diagram and see where you have that sun, moon, and Earth in a straight line. So here I'm looking at a 90-degree angle. This is representing a neap tide where you have the least effect. Again, this is a neap tide least effect. Again, neap tide. So here, illustration D is showing us a spring tide straight line. So the answer is D because you have your sun, the moon, and the Earth in a straight line. The moon and the sun are pulling on Earth's water. So we're going to have the greatest effect between tidal ranges, two very high tides and two very low tides.